you're ready.
Sure thing. I'm just going to quickly introduce everyone to my students. You are not all my students, but you're along for some ice cream, so that's okay. These are my grade 10 academic students, former students from last semester. And they're going to be, are we good, guys? Awesome. What I decided to do for this one is run it kind of like I would run the actual lesson so that people can see how I break everything down. And we're going to make some ice cream, guys. So if I can get you guys hold up your books and stuff and come on over. Well, again, we'll have to be kind of quiet because if there's too much talk, it gives some feedback and stuff like that. They may not hear, even though I got a very loud voice, they may not be able to hear everything that's going on. Okay, so we all enjoy some ice cream once in a while. And a few years ago, I found out that we can actually make ice cream just as good at home as you will buy. And depending on what you put into it, it can even be better. All right, so we just need a few real simple ingredients, and we're going to start off with that. So you guys will break up into groups of like 3 or 4. And what we're going to do is we're going to start with some cream. 10% is good. If you like a little creamier ice cream, 18% is really good. And what we're going to do is we're going to have 2 sets of bags. All right? We're going to have the cooling bag. These are the big bags. And we've got some ice over there, and we'll get you guys to use that. And in a nutshell, it's real simple. Take out one of these bags, all right? Fill it full of ice. Fill it about 3/4 of the way up, all right, with ice. And that's going to be your cooling bag. Then we're going to use these bags right here. And what I would suggest you do is you use 2 of them, all right? This is going to be your mixing bag. And it's real easy. You're going to take a cup. You're going to fill it about to that line with either this cream, the 10%, or the 18%. We're going to take some sugar. Oh, right here. We have to, it's a little hard, so we may have to chisel it up a bit. And we're going to put a whack of sugar in. What I typically tell kids to do is to put usually 4 heaping, because it's ice cream. We want sugar, right? We've got to taste it. So put 4 heaping teaspoons, or maybe even 5 in there. And last but not least, the flavorings. Now, usually I'm a vanilla guy. All right, there's only one type of ice cream in the world that you need to eat that's worth eating, it's vanilla. All right, anything else? However, I found something just as good, maybe even better. So I'm going to get the flavors, and of course I left them up here. Wouldn't that be funny if I forgot them? Where my flavorings going in? We're just here. Move that way, Levi. Okay, so while I'm looking for the flavorings, can you guys get into some ice and start packing it in? Yeah, 3/4 of the way to ice.
Scissors.
Just rip the bag open. Oh my goodness.
I already found them.
On the flavoring. That would have been embarrassing. Oh yeah, Levi, on me. Okay, so guys, a little bit lower in loudness there. So, you know, you can do this with a small group of people, you can do it with a large group. I like breaking this up into different stages, so they're getting the ice. Oh, let's see, ladies. Sometimes I use a little bit bigger of a bag, but this would be, you need enough room that they can actually get the small bag into there. So this might be just a little too much in there. Oh, no, that's perfect. Wait, how's the sugar? Did we, it's all that? Okay, I can just solve it up. Pardon me there. They don't.
Go down.
Yeah, you can put on my head.
Sorry.
Okay, where's that sugar? Oh, you got it. Like go over so you can park the steel a little bit here. There we go.
I see. You just don't have.
Alright. Okay, so I'll get someone else to drop in this. Hey, I'm live streaming here.
We're live, okay?
We're live.
Live on the
Okay,
internet.
get the sugar in. I'm just gonna pull this over here on me. Alright, do we have any questions here? Nope, nothing yet. Yep, so this again would be a little too much ice for the bag. We'd probably want about up to about that level, so it's just gotta take a little bit out. So in a second, what we're gonna do is we're gonna get the kids, this takes about usually 5 minutes or so, depending on how well they can get the bag together. And then they're gonna start mixing. We're gonna let them mix for about 5 minutes. So at that point, I'll kind of talk a little bit about, I'm gonna talk to them about the use of technology, a little bit of chemistry behind it and stuff like that. So I'm just gonna get these guys organized, make sure they're ready to go, and then we're good. Okay, so when it comes to the flavoring, I'm sure we found the vanilla. Okay, this is really important. Now, vanilla is great, but what is even better? 2 drops of lemon, 2 drops of orange blew my mind. Now, don't go too crazy because it is extract, so it's really strong flavoring. Now, what also was impressive, 2 drops of vanilla to 1 drop of mint. Yeah, it was very good.
Yeah, 2 drops of okay. So just what you do?
Yep, put sugar, cream.
So like a citrus ice cream and like a vanilla mint.
Okay, for those of you in TV land, get a capture the bag. What I tell the kids to do, and you'll see that, is I get them to flatten the bag down so that they get as much air out as possible when they go to seal it. So when they put it in, it's like that. The double bagging is actually super important because the ice will puncture the bag, and I've learned that the hard way. And then the bag, the ice cream starts to taste a little funny afterwards. Sorry? Yeah, 2 drops in. Like, no, drops. Like, they go bloop. You gotta make that noise too. You gotta go bloop. Oh, that's why I wouldn't put any more.
Oh no.
And then put some good
How much do you put in? Do 2 vanilla. Just a drop.
no, more in the drop. You gotta do a blip.
Yeah,
Another blip.
Mr. Pilar, you have a question here.
Oh, okay.
He just came in too. He just arrived, it says.
There is a video feed. You should hopefully be seeing the kids and myself. Okay, now before we seal that up, I'm gonna seal yours, Bailey. Okay, everyone take a look and maybe get this again there. So when we go to seal it up, air is, we don't want any air. Air is our enemy here. So watch what I do. I slowly lay it down for a second. See the air bubble here? I push that air bubble out. Hey guys, watching? And then I seal it up. Now the ice, see that? See there's no air in there? Okay, that's super important because air is gonna stop the transfer of heat. So we want the heat to come out of this bag, even though it feels cold. And we want it to go into the ice. We want the ice to cool this down. So we're going to try and suck the heat out. That being said, the ice will puncture. If we only have 1 bag, it will puncture it. So you have to double up on your bags, okay? Otherwise, it'll puncture it. And then no air in the second one as well, too. Well, you're going to mix it in a second. Double bag it first. That's for me. That's just a bad
Double bag it. What are you doing?
Okay, what I do, yeah, I fold this up. So fold that in there a few times. Yeah, just like that. And if you fold it, then it stops there.
This is last semester. I really needed it. wants to know if you can get bonus marks for last.
Sure, I'll go back into your records and I will give you, but this, we can't say that on air, people. Thank you.
Yeah, just, yeah, I'll just see. Just do it for fun.
Just for fun, yeah.
And this year, is that good?
That looks perfect. Oh, I think we put a lot of sugar in it. It's gonna be quite tasty.
You want to talk about how much sugar we put
We
there?
won't talk about that.
Oh, and fish on the air.
Yeah, put some out. No, fish your bag.
Yeah.
Okay, so if everyone could stop and watch me just for a sec again. All right? Or at least 2 or 3 people in your group can. So now what we need to do is we need to make sure we mix everything up in here while we cool it down. So this has been double bagged. All right? Yes, girls, you can see yourselves on the. All right. What you want to do now is get this right into the ice, as far into the ice as you can. Seal this up. Okay. And then once you folded it up, you gotta mix it, just like I'm doing right now. Okay. The mixing will help cool it down, and I'm hoping in 5 minutes we'll have some good ice cream. Once you start mixing, I want you guys at the back of the room, okay? Because it's gonna be super hot.
Mr. Vila, you got another comment.
Okay, we might be having some devices.
I can see the video just fine. It might be the video. Or sorry, it might be because you're on a cell phone. I am recording it and I will send it out likely
So,
tomorrow, possibly
Some other
today.
person talking said they could see it fine, but they said this probably just device issues.
Okay. So let me know if the background noise is too loud that you can't really hear what I'm talking about. Let me guys is on. I watched something good. Figure it out for about 4 minutes. This is nice because you get the chance to break and go. I'm going to quickly tap a little bit up on the board while I'm talking about before I start to make some chemistry. Now, normally I'd be right back there when you thick of it, and I'd be, talking on the whiteboard or something like that. But I'm going to let them go for about 3 more minutes. We're going to realize the quick. So let me it's water and I've done this with grade 2 classes, and I've done this with grade 11 chemistry classes, and you can totally do this with grade 12 classes, and things like that.
Roger just said he got it working on his computer. He's switching his phone to his computer.
Awesome. Good show, Roger. Okay, Regan, you put a timer on and go 1 minute. We'll go 1 minute longer. By 1 minute, you should have something that right timer right. Start. You just start, put 2 minutes on. Does anyone have any questions right now about setting this up? Hopefully a bunch of you are eating ice cream at home. Okay guys, can we have you guys come on back over? Bring your stuff down. We should see some solidification starting to happen. So bring your stuff over, bring it over.
Yeah.
And Bailey, your group started first. So again, we'll try and get everyone to be nice and quiet here while we're close to the mic. Open your top and take your bag out and let's take a look. And you should, at this point, it's been going for about 3-4 minutes. You should start to feel it hardening up now. So check yours right now. I know you guys just started. You've been going for about, I kind of, yours not working too well? Oh, that's not good. What do you think might be the problem?
Maybe we need to do it for longer.
Maybe we need to do it for longer?
More ice because the ice is melting more.
So the ice is starting to melt. What temperature is ice melt at?
0
0 what?
degrees.
Degrees Celsius. Very good. Does anyone know what temperature we actually need to make ice cream at?
I'm gonna say
Does anyone have a phone on them? Someone on their phone, just quickly Google what temperature is needed to make ice cream.
Here's a brand guess, -14.
-4. Okay, that's not a bad guess. That'd be pretty cold on your hands. -4. Do we even know what our temperature of our ice is right now? Okay, so why don't we take a look at that right now? So what I've got here, this is a special doohickey, all right? It's a thermometer. Anyone have a fever right now? We could figure that out.
I'm a little sick. So
Yeah, there you go. No, no.
It says -35 degrees Celsius.
-35 to make ice cream?
That's excessive.
It seems like so. I bet you we could do it a little bit warmer. What we're going to do right now is this. We're going to see what temperature our ice is at. So I'm going to turn on the sensor, and we've got a little Bluetooth device here. Now, Levi, you'll see up at the top. Oop, I'm going to have to move this. Hold on. I got to come around and do this. All right. So you guys watching, and my students are able to look at this because it's on an LCD projector. Wave to everyone. Notice that I'm right up by the Bluetooth symbol. I'm going to click on that, and this device is going to pop up right now. And there's my temperature probe. All right. Okay, so now that my temperature probe is there, I'm good to go. And what happened to our webcam there? It went hiding. That's okay. Oh, there we go. All right, so I can set up a graph of my temperature. So in a second, Levi, I'm going to get you to click on something.
Okay.
Okay, so right now we can, in a second here, start taking some temperature readings. So Levi, click on the little green button down at the bottom there. All right, so now this is taking a temperature reading, and we can see it coming across, and this is room temperature. We're gonna pop it into this ice bath.
You can't see it.
Oh, give it a sec. You'll have to, that's a problem, it's gotta shift everything over there. So we'll see, we can see that the temperature is dropping, and we'll see what temperature it's gonna get down to there, because it looks, we can see it's starting to slope out there, right? I'll see if I can move, you guys can't quite see. There we go. So we can kind of see what's happening now, right? So,
Wait, now you can't see the numbers.
oh, all right, I'll move that. Webcam's in the way. There we go. All right. Now, I know because of my resolution, it's really hard, but this is 1 degree right here. So where does it look like the temperature is going to? How low is it going to go, do you guys think? Why do you say 0?
It just looks like it's like going slowly down like there, and it's just gonna like keep going straight across.
Yeah, and it's, we can see it's flattening out, right? Now, you did some research, you said we need -35.
-35.
Yeah, I did,
No,
Callie, did you find another temperature?
I thought it was
-35. I don't know if
It's
we can
like
get to -35, but if we take a look right now, our ice is in solid form. And what you guys are noticing right now is a fundamental principle with state, meaning if water is in this solid state of ice, and it's pure water, and this is probably pretty close to pure water, its temperature can only go to about 0 degrees Celsius. Can't go lower than that. The temperature is locked in. And the reason for that is because water molecules, the way that we are, we kind of studied them a little bit. Water's got some weird properties we learned about more in grade 11 and grade 12. And it's kind of like a magnet, and water molecules get really nice and close to each other, but it's hard for them to get any closer. And there's this weird thing called hydrogen bonding, and they vibrate All right, and they're actually not as close to each other as they could be. They could get a little bit closer. When they're about 4 degrees Celsius, they're actually closer. But when they go into solid state, some weird chemistry happens, and they kind of form these crystal structures and they vibrate. The problem is they're locked into that pattern of vibrating, and that's why they're solid. We need to unlock that pattern and see if we can get them to drop in temperature more. And that is where salt comes in. So I'm going to pour a whack of salt in here. And that's a scientific term for lots. Oh, that's good. Oh, yeah. Okay, so can you guys seal that bag up and just start mixing it? And what we're going to see now, temperature's going to go back up. Anyone else's bag wants some salt there?
No, Catherine. Oh, son.
This is where it gets loud, guys. Hold on, guys. Put that in the tail. Take over. What? It's melting. Bring it over to the camera. Show everyone that moment. Look at that. Okay, this is not. You can run it. Okay, let's stop. 3, 2, 1. Okay, now notice. Yeah. Oh, what's the problem? It's not just cold. It's so cold. It's freezing. Okay.
Super cooled.
Now the temperature's kind of gone up on the probe. Let's take a look at what happened when we see what's happening in the temperature now. Now compare the change. Notice the drop here compared to the drop before. What do we notice?
It just went straight down.
And what point did it go past?
0.
It went past 0. In fact, where does it look like it's? Well, I don't know, 35. Yeah. I'll come take a look. I'll tell you what these numbers are. Because again, they're really small. Yeah, that's minus 15 right there. And it's still dropping. Maybe we'll hit minus 35. I'm just going to let you guys know. I did this lab up at SATCO with a bunch of grade 8 kids, and they didn't complain once. They were tough kids. No, they didn't complain. But and I brought oven mitts up with me. But you guys, I've got, I don't know if I do have oven mitts back there, but put your mix back in and very carefully mix it up. Don't go too crazy. Yeah, we'll take that out.
It's all she knows.
Whoa.
What, you got them? You have to go back. Okay, you guys take it to the back there to slow fire for the people at home. Another bag.
That was a little bit loud, so they're going to the back
Oh,
now.
you didn't love it? Okay,
So it's not so loud.
there's another bag in case you guys need it. Knowing you probably will.
Actually, not knowing me, knowing my group.
Knowing you will. Okay, I gotta go talk to you. All right, open. I can't see that. Okay, actually, guys, hey guys, can you guys go take it out in the hall? Just so it's a little brighter and I can kind of talk a little bit more. And being I'm on for 8 minutes and then you come back in there. Okay? Yeah. Awesome. Okay, hopefully that wasn't too insanely loud for you guys. So now I'm going to let the kids go for about 10 minutes. Along that time, I'll have a conversation with them. Of course, we're going to cut a little bit shorter today. But I would have a conversation with them. We would go over the chemistry of what's actually happening. What I've done here is I've gotten a screen capture. I would use this definitely on a test. I would give them this exact graph that we generated in class. I would ask them to identify, what stage of the process we're in at each stage in the graph. And what I would do is I would teach them a little lesson about the chemistry of when we go down and lower temperature. The fact that as we break these hydrogen bonds, it takes energy to do that. And that's the heat of, for a real simple way with these guys, they just call it the heat of dissolve. So when those hydrogen bonds are disrupted, it takes energy. We got to pull energy from the ice to do that. So even though it goes down in a liquid state, the molecules can get actually closer together because those salt ions allow for that to happen. And that's able to drop the temperature even lower. In about 8 minutes of mixing this, we're going to have some wonderful ice cream. Some things I found out from doing this: if you use 10% cream, it cools down and it doesn't get super chunky. It's more it's nice and creamy. Sometimes the 18%, even though you think there's more fat, it makes creamier ice cream. It kind of gets really chunky and crumbly. And the 10% seems to chill quicker, probably because there's a little bit more water in it, less fat. That would be something that maybe you could have some kids do some work on. Checking the time, okay. So another thing that I would do next with the kids is I would do a little bit of heat of reaction. So kind of following along the same lines of this lab, I would look at heat given off from a reaction. So I would get a student to fill 100 mils of water into a container like this, a calorimetry container, and I would put some sort of food. Now here, bugles give off a tremendous amount of energy. I don't know if we have tons of time to do that today, but I'll definitely do that with these guys on Friday, and we'll check that out. And I'll teach them a little bit about how we can measure calories in a reaction. And again, it's the same thing. We put the thermometer in. We've got the water usually a little bit cool because it's coming out of the tap, 4 degrees, and they can see that happening. I set up whatever I'm going to burn down here. I light it up, and we see the temperature start to go. And then what I have the students do, real simple, is look at the starting temperature and the finishing temperature and see what the temperature is in between. Once we do that, the kids then use Q equals MC delta T, and they determine how many calories or how many joules, whatever you want to use, we're giving off in that reaction. So this will be something I'll do Friday with the team, and I'll probably videotape it and throw it up on Twitter there, just because I know we're after 4 right now. And I gotta bring the kids back in to check out how their ice cream's going. So I'm gonna go grab one group and get them to come in and show you guys how their ice cream is holding out. Okay, Bill, bring yours in. And Catherine, you come with.
Didn't help at all.
Didn't help at all.
No, and look what it did to my arms.
Oh yeah. You show everyone at home what's happening.
First off, I'm freezing out. Okay, hurry up. Actually.
Oh, so what are you here? Let's make sure you're facing the camera there so everyone can see. So what do you notice there?
It's thicker and it's not like really as liquidy as it was. It's getting the ice cream.
Yeah, it's getting ice creamy. We'll take a little bit out and get you guys to test it, see if it's tasty, and then you probably, not Catherine, okay, not for Catherine. I think you'll probably need another 3-4 minutes, but we'll get you to try out some right now.
What flavor is that?
Yeah. Still a little liquidy in there. So So that's Catherine's because there's less, and then this is yours. Okay, make sure everyone can see at home there. Let's do a taste test here. Let everyone know how good it is.
It's good.
Yeah?
But needs more time.
No more time? All right, let's seal this bad boy up. We'll send you guys back out
But
there.
when you're mixing with
So you set a timer. You make Catherine mix it with her bare hands for the next 4 minutes.
and you don't.
Yeah. Yeah, and one thing for everyone to know, this is very messy. Poor Bailey's got salt all over because she's working hard and probably because she's not getting much support from Catherine. Right?
I'll grab my phone.
Yeah. You grab your phone and time it. Okay. You got get another bag here. You guys are losing cooling here. There you go. All right, let the mixing begin. Be gone.
Okay, ready, Captain?
Okay, any questions or anything like that about, I think we've minimized the chat here. All right. No questions or anything like that? I'm going to go grab another group and see what theirs looks like. Okay, who's been mixing for a while here? You guys come on in. Right? So here's a good example. Like, look at this, guys. See how liquidy yours is, and it's leaking all over. Not a slipping hazard at all. Grab another bag here. Yeah. Okay. In there. All right. How are your hands doing?
They're cold.
Very cold, eh? All right. So let's take it out. Let's take a look and see what we've got here. Oh, look at that.
Is it good?
Show it to everyone at home
Don't
there.
announce it.
No, not that close. We're not gonna be able. So tell them what you noticed.
It's
Without cursing, preferably. Let's go out to Canada. Good job, Michaela.
it's a lot creamier and like more solid. Anyone else have any words they want to say? Oh, it's cold. It's cold, just like ice cream is.
Yeah.
Okay.
So let's take it, open it up. I got some spoons here. You guys can. What did you use for your flavor?
Vanilla.
No one went with the. No one wanted to try it out.
Not ready.
What?
The timer is done.
The timer's done. So take a look, nice and quietly. Okay, scoop it out. Let's see what we got here.
Someone help.
Touch my.
Oh, look! Get that on camera. Look at that. Oh, I don't know if you'll hold it up so that they can actually see the consistency. Nice. Mr. Bilot's going to try a little bit here. Everyone uses their own. Okay, you can't put that spoon back in there.
I'll have
Oh, this is great. You guys put the right amount of sugar in. As in a lot.
Yeah, a lot.
Okay, eat that right now. You guys,
I'll get straight over the base.
yeah. Okay, you guys be gone, and you guys come on over. Let's take what did you use? Did you use the 18% or the 10? Okay, yours is.
Oh, here comes the next group.
So we're moving on to this group.
Okay. Four. Yeah.
Mix it for long, guys. Ready?
Yeah, just mix it for longer. And you know what? You're probably not mixing it as hard because you got those gloves on.
No, I was mixing it. You should see my hands. I do this.
Yeah? Okay, go back out in the hall there.
Okay.
Adults will talk here.
Sorry.
No problem.
Can you start talking?
I don't know. I didn't buy it. Okay, so I'm not sure. It doesn't look like. Oh, wish we could try. Let's not. It actually is really good. In fact, it tastes just as creamy as the stuff that you would get at you buy in a store, and you know the ingredients in it are pretty straightforward. So I've had kids come back and tell me that they've done this at home. Usually they come back and say they made a horrible mess, and their parents were happy about the ice cream, but not so happy about the mess. One thing you'll need to do, because the water is salty, is you'll have to wipe down all the dust really well. How's yours there? That's creamy, you mean? You're okay? You guys try it out anyways. Okay, yeah, so I'm not sure, Rhonda, if you want to take over at this point. Oh, do you need to add any special salt? And how much? Okay, so this is where the beauty of inquiry comes in. I've done this before, like when I've had an entire class where I get students to experiment with different creams, different amounts of salt, different types of salt. And this is where you can pull the inquiry into it. So if I wanted to really extend this and go for another day with it, you know, or you know, do this sort of as a do a follow-up to this later on in the week, I would have the kids go home and plan out what they might want to change, because there's different types of salt too. So that's pretty neat. Any other questions?
Jason, Cheryl in Alberta is asking, she has passport temperature sensors. I believe you're using the wireless temperature sensors. Can you just hold up the temperature sensor you're using, just so everybody can see what you're using? Cheryl, I'll send you some information on how you would use your passport temperature sensors with your new AirLinks that you should be receiving this week, I would think. I will follow up with you on how to do this experiment. It's the exact same way. It's just all we do is plug in the passport temperature sensors to the AirLink.
And a big thing when you're doing this, like I've done with the classes before, and I do with the grade 9s, that if we just stopped it now and the kids made the ice cream and then they went, the learning would kind of end. So like, I think it's really important that when you generate data like this, that's got bumps and things, and if you can take a look at where the air temp, we took the thermometer out of the bag and the temperature started to rise, I have the kids go down and isolate each stage, what was happening during this curve stage, what is happening there, what's happening at the flat part, why is the temperature going up again? So they have to recollect what happened and then tag all those places. If this was a grade 11 class, I would say, okay, you know, if there's, when the temperature is dropping the second time, I want you to show me using models what's happening to the water molecules. How are they different at each stage? So when it's ice stage, what do the water molecules look like? When they're starting to liquefy, what do they look like there? Tell me about the intermolecular forces of attraction. Is anything disrupting them? I would put this on the test. I would take this this data and I would put the graph on the test, just because the more we expose our students to using the data that they collected more and more often and showing them more and more real world data, I could later on get a journal that dealt with, say, testing temperature in freezing roads and using different forms of salt to see which ones work better to reduce or increase the friction. The kids are going to see graphs that don't look perfect like they see in textbooks. And I think the more often we show them graphs that don't look perfect and they have to try and figure out what's going on, definitely the better. How are we doing there, guys?
I was pretty good.
Well, let me get a spoon in that hasn't been dirty. Don't double dip in first.
I think it's good.
There you go.
That's good.
That's pretty good consistency right there.
It's a
Oh,
little
and you guys put the nice.
good.
Oh, you're dripping all over my floor there.
Oh, sorry.
Mm,
I didn't get
right. Good. Sure thing. Okay, can you guys say a quick goodbye?
Bye.
Yes, you guys made great ice cream, and thank you for being such good sports. Okay, if there's any other questions, if not, I'm going to let these guys clean up, and it's probably going to get real loud in here.
This one's for me.
Okay.
Okay, I'm just.
Well, thank you everyone for coming. Oh. Thank you everyone for coming, and thank you to Jason and his class for presenting this webinar.
No problem.